Ionic equilibrium. Let us continue. In the ionic equilibrium, we have discussed pH and pOH. We have discussed. Next, we will discuss common ion effect. Common ion effect we will discuss. Now we will take acetic acid. We will take. To this, let us add water. Let us prepare aqueous solution of acetic acid. In this aqueous solution of acetic acid, what and all will be there, that we will see. We have taken acetic acid that dissociates to give acetate ion and H plus ion. These are the species will be there in the aqueous solution of acetic acid. That means this will be at equilibrium. This will be at equilibrium. So at equilibrium, concentration of acetic acid is X molar, concentration of acetate ion is Y molar, concentration of H plus is Z molar. So in the aqueous solution of acetic acid, so and so species present at equilibrium. Then another equilibrium is present. What is that? In the sense, water is in equilibrium with H plus and OH minus. H plus and OH minus. This equilibrium also will be present. Now, in this equilibrium, we need not consider concentration of water. Why? Because concentration of water remains constant. So that we need not consider. Concentration of H plus and concentration of OH minus we have to consider. So at equilibrium, concentration of OH minus is suppose A molar. What is the concentration of H plus, do you feel? Sir. So now, before discussing this, let us take pure water. Pure water we will take. In pure water, equilibrium is present. What is the equilibrium? In the sense, H2O liquid is in equilibrium with H plus aqueous and OH minus aqueous. In the pure water, liquid water is in equilibrium with H plus aqueous and OH minus aqueous. Now, Kw is equal to, Kw in the sense ionic product of water, that is equal to concentration of H plus into concentration of OH minus. Now, how the concentration of H plus and OH minus will be there in the pure water? Will it be same or different? For that, how H plus and OH minus is produced, that if you know, then we can say. Now, water we can write like this. In this, oxygen is having 2 lone pairs. Now, oxygen electronegativity is greater than hydrogen. Therefore, the bond pair is shifting this side. So, hydrogen leaves the bond and detaches. Leaving the bond in the sense, it is getting lost. Therefore, it is getting +1 charge. So, hydrogen is getting +1 charge. Oxygen is gaining the bond. So, oxygen is gaining the electron. So, oxygen gets a negative charge. That is called OH minus. So, water on ionization gives H plus and OH minus ions. One water molecule on ionization gives 1 H plus and 1 OH minus ion. Therefore, at equilibrium, how the concentration of H plus and concentration of OH minus will be there in the pure water will be equal. So, will be equal in the sense, suppose if you write concentration of H plus is suppose B molar, if you write concentration of OH minus also B molar, both will have equal value. Therefore, we can say that Kw is equal to concentration of H plus square or concentration of OH minus square. Like this we can say. Sir, now we will take temperature 25 degrees Celsius. At 25 degrees Celsius, pure water contains H plus ion, that is 10 power minus 7 molar. Contains OH minus ion, that is 10 power minus 7 molar. Now we will see the Kw. Kw is equal to concentration of H plus we will substitute, concentration of OH minus we will substitute. We are getting how much in the sense this much we are getting Kw. Kw value is this much. Okay. Now we will take a pure water for which we will find pH. pH is equal to minus log of concentration of H plus. Now we will substitute H plus concentration. Now we will get pH is 7. So pH of pure water is how much at 25 degrees Celsius in the sense we can say 7 we can say. Now we will find pOH. pOH is equal to minus log of concentration of OH minus. So minus log of OH minus concentration substitute, that is 10 power minus 7. Therefore pOH is equal to 7. So we got pH of pure water, that is 7, pOH of pure water 7 at 25 degrees Celsius. Now let us take a pKw. pKw is equal to pH plus pOH. pH plus pOH. Substitute pH and pOH. We are getting pKw how much in the sense 14. So pH of pure water is 7 we got. Okay. pH of pure water is 7 we got at what temperature in the sense at 25 degrees Celsius. At 25 degrees Celsius we got so and so. Okay. So at here at 25 degrees Celsius pH of pure water how much we are getting in the sense 7. Now pure water in the sense whether it is acidic or basic or neutral, what we can say? Pure water is acidic shall we say, or basic shall we say, or neutral shall we say? Which one we have to say? Pure water in the sense we know that that is neutral. That is neither acidic nor basic. That can act as acid as well as base depending on the other substance, isn't it? Therefore pure water we can say as neutral we can say. Why do we say pure water is a neutral? Because concentration of H plus is equal to concentration of OH minus. Isn't it? Pure water is equal to neutral we are saying. Why? Because concentration of H plus is equal to concentration of OH minus. That's why pure water is neutral. So what is the pH now? pH is 7. pH of pure water is 7 at 25 degrees Celsius. Okay, sir. Next we'll take, now we are taking pure water. Now we are taking pure water. At what temperature in the sense some other temperature we will take. Suppose we will take temperature is some 35 degrees Celsius, otherwise 50 degrees Celsius, like this we will take. That means greater than 25 degrees Celsius we are taking. Temperature of pure water we are taking greater than 25 degrees Celsius. So now we have taken pure water, temperature is greater than 25 degrees Celsius. In this pure water equilibrium is possible. What is the equilibrium in the sense? Equilibrium is so and so equilibrium. Now at equilibrium, how the concentration of H plus and OH minus will be there in the pure water? Will be equal or not? Will be equal because it is pure water. Water ionizes to give one H plus and one OH minus. One water molecule on ionization gives one H plus and one OH minus. Therefore, H plus concentration is X molar, means OH minus concentration is X molar. So now we'll find Kw experimentally for pure water. It comes as 10 power minus 12. Okay, we have taken temperature greater than 25 degrees Celsius. When the temperature is greater than 25 degrees Celsius, Kw is how much? That we will see. Okay, Kw is how much we will see. Now, at this temperature, when the temperature is 25 degrees Celsius, Kw is how much in the sense 10 power minus 14 molar square. Okay, when the temperature is 25 degrees Celsius, Kw of pure water is 10 power minus 14 molar square. Now the temperature is greater than 25 degrees Celsius. Temperature is greater than 25 degrees Celsius means what is the Kw value? Kw is called ionic product of water. It is nothing but equilibrium constant. What is the Kw now? Do we say, how much shall we say? For which? What is the characteristics of equilibrium constant, you think? Equilibrium constant depends on which factors, you think? We said equilibrium constant depends on temperature. Sir. So we studied one point, equilibrium constant depends on temperature. If the process is endothermic, on rising temperature, equilibrium constant increases, we said. For endothermic process, on rising the temperature, equilibrium constant increases. Rise in temperature favor endothermic process because endothermic process absorbs heat from surrounding. Therefore, here temperature is greater than 25 degrees Celsius. You have increased the temperature. What will happen to the equilibrium constant? Equilibrium constant certainly changes. Whether increases or decreases. Shall we say greater than 10 power minus 14 or greater than less than 10 power minus 14? What shall we say? At 25 degrees Celsius, kW of pure water, we said 10 power minus 14. Now temperature is greater than 25 degrees Celsius. Now shall we say kW is greater than 10 power minus 14 molar square? Yes or no? How do we say yes? That means you see the forward. Forward is what? Dissociation, ionization. Dissociation in the sense, no doubt, that is endothermic. Forward is a dissociation. Therefore, that is endothermic. Bond is breaking in the forward. Backward, if you see H plus and OH minus associating to give water. So backward is association. So association in the sense formation of bond. So backward is exothermic, but forward is endothermic. Forward is endothermic. Therefore, equilibrium constant for this process is greater than at 25 degrees Celsius. Therefore, greater than 10 power minus 14. For example, let us take 10 power minus 12 molar square. Okay. So, for example, we have considered corresponding that certain temperature will be there, no doubt. So, in the pure water at equilibrium, concentration of H plus is x molar, concentration of OH minus is x molar, we said. Now, we will substitute in Kw formula. Kw is equal to concentration of H plus into concentration of OH minus. Therefore, is equal to what we can say means concentration of H plus square, we can say, because both are having equal value. H plus concentration equal to OH minus concentration, therefore H plus square, we said. Now we are substituting Kw we are substituting 10 power minus 12 molar square equal to concentration of H plus square. From this we are finding concentration of H plus, that is how much in the sense 10 power minus 6 molar. From this let us find pH. pH of pure water let us find. So pH of pure water is equal to, what is the formula? Minus log of H plus concentration. So minus log of H plus concentration, let us substitute 10 power minus 6, let us simplify 6. So pH of pure water is how much? Means 6. Now we will find pOH of pure water. pOH of pure water in the sense minus log of OH minus, substitute OH minus concentration, that is 10 power minus 6, pOH is equal to 6. Let us find the sum of pH and pOH, that is how much in the sense 12, that is equal to pKW. Now you say that what is the nature of pure water now? pH of pure water we said 6. pH of pure water is 6 now. What is the nature of pure water? Shall we say acidic or basic or neutral? What shall we say? Here we said, here we took temperature 25 degrees Celsius. We took pure water, we took temperature 25 degrees Celsius. pH of pure water we got 7. pH of pure water we got 7 here. We said pure water is neutral. Why it is neutral? In the sense concentration of H plus is equal to concentration of OH minus. Therefore, we said it is neutral. Now we took here also pure water. This temperature is, here temperature of pure water is greater than 25 degrees Celsius. Here we got pH of pure water 6. Now we will see what is acid, that we will see. Acid means what? Okay. Now we will take aqueous solution of some acid. Aqueous solution of some acid. For example, aqueous solution of HCl, aqueous solution of sulfuric acid. In the laboratory, we can say dilute sulfuric acid, dilute hydrochloric acid, dilute nitric acid, dilute acetic acid. Why? You might have seen vinegar in your home. Vinegar is what? Aqueous solution of acetic acid. So that most of the acids we are using, that is aqueous solution of acid only. For preparing rasam also, we are using a tamarind. So we are dipping tamarind in the water. After immersing for a certain time, tamarind juice will be prepared. Tamarind juice in the sense that is tartar, that contains tartaric acid, that therefore aqueous solution of tartaric acid, that is. So lemon juice we are taking, that is aqueous solution of citric acid. So that we are coming across many aqueous solution of acids in the day-to-day life. In the aqueous solution of acid, what will be there? Certainly H plus will be there and OH minus will be there. Both will be there. Aqueous in the sense, we should write H plus and OH minus. Aqueous word, if you see, immediately you have to come to know that H plus ions and OH minus ions will be there in the solution cell. Now we have taken aqueous solution of acid. In that H plus will be there, OH minus will be there, both will be present. Sir, now we will take aqueous solution of base. Aqueous solution of base. Aqueous solution of base in the sense, which base we are coming across? Aqueous solution of base in the sense what? We know that what in the sense limestone rocks we know. That limestone rocks will be strongly heated. What will happen in the sense we will get quicklime, we will get. Quicklime is what in the sense calcium oxide, CO. That quicklime, how it will be there in the sense it will be like white, it will be like stones. It will be like stones. That quicklime, calcium oxide, drop into water. What will happen, do you know? Immediately water starts boiling. That means calcium oxide, quicklime, combines with water to give calcium hydroxide. Okay, so that is aqueous solution of a base. That aqueous solution of base, that also we know. So in that aqueous solution, what will be there means H plus ions will be there and OH minus ions will be there. Both will be present. Now I will take what in the sense pure water I will take. Now I am taking pure water. In the pure water, what is there means H plus ions will be there, OH minus ions will be there. Both will be there. Okay. Now see that here this point carefully listen. Acid means concentration of H plus will be greater than concentration of OH minus at whatever the temperature. Acid in the sense, acidic solution in the sense, acidic solution means in that concentration of H plus will be greater than OH minus at whatever the temperature. Aqueous solution of base, basic solution means in that concentration of H plus will be less than concentration of OH minus at whatever the temperature. Pure water in the sense, pure water is always neutral at whatever the temperature, therefore concentration of H plus always equal to concentration of OH minus. Okay, therefore if you now I will give some points. If concentration of H plus is equal to concentration of OH minus in a solution, that solution is what we do not know. If concentration of H plus is equal to concentration of OH minus in a solution, then you have to say that is neutral. You have to say that is neutral. This solution in the sense here not only water is present, some other substance also present. Okay. So if you take pure water, suppose I am taking pure water. In the pure water in the sense, in the pure water concentration of H plus always equal to concentration of OH minus irrespective of temperature, and it is neutral, always neutral. If concentration of H plus is greater than concentration of OH minus in a solution, then we have to say that solution is having acidic nature, we have to say. If concentration of H plus is less than OH minus concentration in a solution, then that solution we have to say basic solution. Okay. So temperature can be whatever the thing. What we have to see, whether the solution is acidic or basic or neutral, in the sense what we have to see. We have to see we have to compare concentration of H plus and OH minus. If they are equal, then neutral, that's all. If H plus is high, then it is acidic. If H plus is low, then it is basic. Like that only we have to say. Okay. Now we will take a, we have taken a pH of water is how much in this? Here we have taken pure water. Temperature is greater than 25 degrees Celsius. Here concentration of H plus is equal to concentration of OH minus here. In pure water, in the sense H plus concentration is equal to OH minus concentration. For this, Kw is equal to what, in the sense 10 power minus 12. Here H plus concentration is 10 power minus 6. OH minus concentration also 10 power minus 6. pH of pure water is 6. pOH of pure water is 6. Here in this pure water, H plus concentration is equal to OH minus concentration. Therefore, the pure water is neutral. Okay. So that don't think that if pH is 7, neutral, pH is less than 7, acidic, pH is greater than 7, basic. That point is when the temperature is 25 degrees Celsius. Okay. Therefore, now at 25 degrees Celsius, we can say pH is equal to 7 means neutral. pH is less than 7 means acidic. pH is greater than 7 means basic, we can say, at 25 degrees Celsius. If we change the temperature, the pH at neutral will change. If we change the temperature, the pH at neutral point will be different. Okay, suppose I will take temperature less than 25 degrees Celsius. Now, for neutral solution, pH is less than 7. For example, pH is equal to here less than 7, in the sense less than 7 not. Here how much will be there, means pH is greater than 7. Suppose 8. For example, 8 we have taken. If temperature is greater than 25 degrees Celsius, for neutral, whether it is pure water or neutral solution, pH will be less than 7. For example, pH is equal to 6. Okay. So if you change the temperature, what will happen means position of equilibrium will be affected. Therefore, everything will change. Okay. Previously, you know that this statement you know. That means what statement you know, in the sense general statement. Everyone knows this. pH is equal to 7 means neutral. pH is less than 7 means acidic. pH is greater than 7 means basic. This is, we know that. It is superficial. Now, if you see clearly, what is that means? pH is equal to 7 for neutral solution or pure water at 25 degrees Celsius. If you change the temperature, pH of neutral solution will change. Okay. Now we will take, in this case, at 25 degrees Celsius, pH is equal to 7 for neutral. pH is less than 7 for acidic. pH is greater than 7 for basic. Okay, greater than 7 for basic. Now, temperature is less than 25 degrees Celsius. pH is for neutral solution, pH is greater than 7. For example, pH is equal to 8 for neutral solution. Then, now if you consider this point, as per this point, if you take pH is 7, that is acidic. Okay. If you take pH is 9, that is basic. That is basic. Now we will take temperature greater than 25 degrees Celsius. Temperature greater than 25 degrees Celsius means for neutral solution, pH is less than 7. So suppose for neutral solution, pH is equal to 6. For neutral solution, pH is equal to 6. Now we will take a pH is equal to 5. 5 in the sense the solution is acidic. pH is equal to 7 if I take, the solution is basic. Therefore, we have to see the temperature, we have to see. If temperature changes, pH of neutral solution also changes. Okay, therefore neutral in the sense how to say whether the solution is neutral, in the sense if the concentration of H plus is equal to concentration of OH minus, then only we have to say the solution is neutral. Okay, so that what is the conclusion? For neutral solution, H plus concentration is equal to OH minus concentration. For acidic solution, concentration of H plus greater than concentration of OH minus. For basic solution, concentration of H plus less than concentration of OH minus. Therefore, pH is equal to 7 for neutral solution, no doubt, if temperature is 25 degrees Celsius. If you change the temperature, then don't say pH is equal to 7 for neutral solution. Okay, sir. Now, next point we will see. Now we will take acetic acid. To this, we will add water. We are preparing what in the sense aqueous solution of acetic acid. Now, in this, what is the equilibrium present means acetic acid ionizes to give acetate ion and H plus ion. This equilibrium is possible. At equilibrium, undissociated acetic acid will be there. That means this will be there. That concentration, suppose A molar. Acetate ion will be there. That concentration is suppose B molar. H plus will be there. That concentration also B molar. Acetate ion concentration is how much? Same value will be there. H plus concentration also. There is no doubt. Why? Acetate ion concentration and H plus concentration both are equal. How do we say they are equal? Because how do we say they are equal in the sense acetic acid, acetic acid we can write like this. In this acetic acid, the bond is shifting like this. Therefore, it becomes O minus, it becomes H plus. Therefore, one acetic acid molecule gives one acetate ion and one H plus ion. Therefore, we can say concentration of acetate ion and concentration of H plus ion is equal. Sir, in this solution, another equilibrium also present, because aqueous is given. Aqueous in the sense immediately write like this equilibrium. You write like this equilibrium. Now, at equilibrium, concentration of water means don't take undissociated water concentration, don't consider anywhere. Why? Because its concentration remains constant. Aqueous in the sense water is excess. Therefore, concentration of water remains constant. So don't consider it. Okay. Now H plus concentration and OH minus concentration we have to say. So now you say that how the H plus concentration and OH minus concentration will be there. How much value shall we say? Now temperature is given that 25 degrees Celsius. Kw value is given that 10 power minus 14 molar square. So what is the concentration of OH minus and H plus, do you think? Shall we say that it is 10 power minus 7 molar, it is also 10 power minus 7 molar? Because Kw equal to 10 power minus 14, Kw is equal to what is the formula? Concentration of H plus into concentration of OH minus. We know Kw value. Kw value. So shall we say? How do we say Kw value? How do we say Kw is 10 power minus 14? 10 power minus 14 at 25 degrees Celsius, we said for which one already? We said for which one? You see that when the temperature is 25 degrees Celsius, Kw for pure water 10 power minus 14 molar square we said. When the temperature is 25 degrees Celsius, for pure water Kw equal to 10 power minus 14 molar square we said. Isn't it? Now what solution we have taken? We have taken aqueous solution of acetic acid only, no? Here for this solution, like this equilibrium is possible. For this solution, why do we say Kw equal 10 power minus 14? Is it correct or wrong? We will see equilibrium constant characteristics. Characteristics of equilibrium constant depends on what factors we will see. Equilibrium constant depends on temperature. Okay, we kept temperature same. We kept temperature same, 25 degrees Celsius. Okay, leave it. Temperature is not a factor. Equilibrium constant depends on nature of reactants and products, isn't it? That point we have seen in the characteristics of equilibrium constant. Equilibrium constant depends on nature of reactants and products. So equilibrium constant depends on nature of reactants and products, means you see that this one you see, and even you see pure water. You take pure water. In the pure water, what equilibrium is there? H2O is in equilibrium with H plus and OH minus. Here we can say concentration of H plus is x molar, in the sense concentration of OH minus also x molar, both are equal value. Temperature 25 degrees Celsius, if we take Kw is equal to 10 to the power of minus 14. From this we can say concentration of H plus is 10 power minus 7 molar, OH minus also 10 power minus 7 molar, we can say. Now can we say in this solution, shall we say Kw equal 10 power minus 14? Yes, of course we can say. Because why? Because here you see the equilibrium, here you see the equilibrium. In this equilibrium, what is there? Left side undissociated water molecule, here also undissociated water molecule. Right side, what is there? In this equilibrium, H plus and OH minus ions, here also H plus and OH minus ions. Therefore here equilibrium left side and right side, here equilibrium left side and right side, species are not different. Therefore here equilibrium constant and here equilibrium constant certainly same. Okay, correct. Sorry. So we said here Kw for pure water, Kw is 10 power minus 14 at 25 degrees Celsius. Even for aqueous solution of acid also, for that Kw for this equilibrium is 10 power minus 14 at 25 degrees Celsius. In that there is no doubt. You take even aqueous solution of base. In that also, like this equilibrium will be there. For that also Kw equal to 10 power minus 14 molar square. So whatever the aqueous solution you take, whatever the acid, whatever the base you take, anything, Kw will remain same. That's all. If we keep temperature same. Therefore, for pure water, what is a Kw? Same Kw for even for aqueous solution of acetic acid at 25 degrees Celsius, provided temperature should remain same. Okay, sir. Now the question is here pure water, temperature 25 degrees Celsius, Kw 10 power minus 14, H plus concentration is 10 power minus 7 molar, OH minus concentration is 10 power minus 7 molar. This okay. In this pure water, concentration of H plus is equal to concentration of OH minus, that we know. Now we have taken aqueous solution of acetic acid. It is at 25 degrees Celsius, Kw equal 10 power minus 14. Now so and so equilibrium is present in this aqueous solution of acetic acid. Now you say, what is the concentration of H plus and what is the concentration of OH minus for this equilibrium in this solution? Shall we say here 10 power minus 7, here also 10 power minus 7? Shall we say or not? What do you think? We should not say. Why we should not say? Because it is acid. Acid means what we have to say? Concentration of H plus is greater than concentration of OH minus. Yes or no? So in this aqueous solution of acetic acid, for this equilibrium H plus concentration, should remain same. In the, suppose we are taking vinegar. Vinegar is called a dilute aqueous solution of acetic acid. In that vinegar, like this equilibrium is possible, like this equilibrium also possible. Shall we say that some of the H plus ions in the vinegar will be in this equilibrium? Some of the H plus ions in the vinegar will be in this equilibrium, and can we say that can we distinguish so and so H plus is from acetic acid, so and so H plus is from water? Like this, can we distinguish in the vinegar? Practically, you think. Practically, you have seen vinegar. You know that how vinegar is there. So that we cannot say that in the vinegar, see that these and all H plus ions, these from acetic acid, these and all H plus ions, these from water. Like this, can we say? We cannot say. Therefore, concentration of H plus in the aqueous solution of acetic acid is one value. Okay. So what value you will substitute concentration of H plus in this equilibrium? Same H plus concentration you have to substitute here also. So that here H plus concentration and here H plus concentration will remain same. But OH minus concentration will be less than H plus concentration. But the product of these two concentrations is how much in the sense 10 power minus 14 at 25 degrees Celsius. Okay, the product of these two concentrations will be 10 power minus 14 at 25 degrees Celsius, but H plus concentration need not be equal to OH minus concentration in this solution. That's why this solution is acidic solution. Sir, okay. So what is the concentration of H plus and what is the concentration of OH minus? How do we know it in this case? That we will see. Okay, sir. Now first I will take a pure water. I am taking pure water at 25 degrees Celsius. I will take. In that pure water, equilibrium is possible. What is the equilibrium in the sense? H2O is in equilibrium with OH minus. Here concentration of 10 power minus 7 molar per H plus and OH minus is 10 power minus 7 molar at 25 degrees Celsius. Okay. I have taken just pure water only. I have taken temperature is 25 degrees Celsius. At this temperature, so and so equilibrium is possible. H plus concentration is this much. OH minus concentration is this much. Okay. To this, let us add acetic acid. We will add. What acetic acid means? Glacial acetic acid. Glacial acetic acid means 100% acetic acid, that is pure acetic acid crystals. That glacial acetic acid I am adding into this pure water and I am getting what in the sense? Aqueous solution of acetic acid. I got aqueous solution of acetic acid. Sir. So instead of acetic acid, we will take HCl. We will understand easily this one. Okay. Therefore, now we will take HCl. We will take. That means what HCl in the sense? 1 mole of HCl gas we are passing. This is pure water is 1 liter. Like this we'll take. So we have taken pure water 1 liter, 1 mole of HCl gas we have passed. Okay. Now we will take in this is aqueous solution of HCl now. This is what in the sense aqueous solution of HCl. Now in this aqueous solution of HCl, what is the equilibrium is there means H2O is in equilibrium with the H plus and OH minus. This concentration how much means 10 power minus 7 molar. This concentration is 10 power minus 7 molar. Now we have passed 1 mole of HCl gas. HCl gas dissolves in pure water. Therefore, we are getting aqueous solution of HCl. It is how much in the sense 1 liter. 1 liter of aqueous solution of HCl contains 1 mole of HCl. So concentration of HCl is 1 molar. This HCl dissociates to give H plus ions and Cl minus ions. How much HCl will dissociate in water? Complete. Therefore, it is strong acid. Therefore, how much H plus is produced from HCl? 1 molar. HCl dissociates completely. Therefore, it is giving 1 molar H plus. And how much Cl minus in the sense 1 molar Cl minus. Now, this H plus goes to this solution only, no? This H plus present in this solution only, no? Therefore, water providing, that means this much H plus concentration we have written as per this. Now HCl is providing this much concentration. Therefore, what happens to the concentration of H plus? 10 power minus 7 plus 1 molar. Concentration of OH minus is 10 power minus 7 molar. Now see, to this equilibrium stress is given or not? Here pure water we have taken, pure water is in equilibrium, no? Pure water is in equilibrium in the sense. Now pure water is in equilibrium, no? We have added HCl in the sense, we have added HCl. We have added HCl in the sense that HCl dissociates to give H plus. HCl dissociates to give H plus in the sense concentration of H plus. We are rising in the equilibrium. We are rising. That means we are giving